All right, folks, thanks again for joining us. We've got, I think, everybody who's going to be here, and so we're going to get started. So this is a follow-up webinar. We had a webinar, I think a little bit over a month ago. We showed you folks lots of different scenarios that people are using the combination of Starlink and Peplink out in the field. And there's lots of reasons why people are doing that. And so today we're going to go one step further and show you actually how to configure Peplink and Starlink when you're using it out in the field. Before we do that, though, we're going to talk a little bit more about some of the background here. Starlink and Peplink, it's a really popular topic right now, and I think there's a lot of reasons for that, but we'll dig into that a little bit before we show you how to configure everything. For those of you that don't know our guests today, we've got Peter West from West Networks. We also call him Professor P. He's running the Peplink U webinar series, again, focused on showing you how to configure all sorts of the great features in Peplink. So thank you, Peter. And then we've also got Martin Langmaid. Martin Langmaid is from Ven Telecom over in Belgium, but he's located in the UK. Thank you, Martin, for joining us as well. And myself, Travis Durick. I'm product manager here at Peplink. So Peter and Martin have a whole bunch of hands-on experience with Starlink out in the field, and myself a little bit as well, but definitely those two have deployed, I think, more Starlink dishes than just about anybody out there right now. And I think to open this up, again, we want to give you a little bit more background as to why we're talking about Peplink and Starlink, right? Starlink's there, and yeah, I can get internet from space, and that's great, right? But there's more to it, right? And it's not just that simple. And so I think to start out, we're going to talk about some of the different connectivity options that are out there and start to compare these things and show you kind of how unique Starlink is, but also where some of the problems might lie when you're using Starlink as well. Peter, I think you really kind of wrapped this up in a way that I found super easy to understand in terms of explaining the different connection types and the different kind of promises or rights behind those different connection methods. Do you want to just kind of walk me through that again? I thought that was super interesting and helpful.
Definitely, and thank you for having me on this webinar. Share more information with people. Yeah, so a lot of times when we're talking about connectivity and expectations, they don't necessarily go hand in hand. You know, you have carriers saying, "Hey, we offer, gigabit throughput," or 5G is the next thing, and it can go up to 10 gigs. But we have to ask, what does that mean, and where are we at, and what the SLA or the quality or guarantee of that service might be. And so I've defined the internet or internet providers as three different options. And this is by no means documented or a standard. It's my way of explaining it to myself to comprehend it. But if you think of let's start with the best. You think of something like a fiber circuit. You sign a contract, you have an SLA, you get 1 gigabit of internet, and you're paying for 1 gigabit internet. And if you don't get 1 gigabit, they owe you something. They owe you a technical response. They owe you maybe a credit on your bill, if you can prove, which good luck, but if you can prove that you're not getting it. And so we call that SLA service, right? Service level agreement. I'm getting what I pay for, and I know I'm going to get that. Then you have your FiOS, your cable modems, your DSL modems. These guys are what we call, they are services that you pay for a speed range. Like I'm going to pay for a 100 by 10 megabit or a 300 by 50 meg cable modem or FiOS or whatever, maybe even a gig by a gig FiOS or some variant thereof. But there's no SLA associated with them. What they're doing is they're out there selling these services, and they're filling up their POPs, or their points of presence, and I've got hubs, and those hubs have maybe a 1 gig or a 10 gig circuit to it, and then they're selling 300 1 gig lines. And so we call this best effort. What they're doing is saying, hey, you can get up to a gig, but not necessarily you're going to get always a gig. And so I call this best effort. And the reason why this is so different than the next level is they are at least trying to give you that throughput. And that's the difference. They have a subscription algorithm. They're monitoring the usage on their hubs, and they say, hey, we want, if you do a speed test, we want to see that the majority of the time you're getting that gig of throughput. And so that's why we consider this best effort. They're going to do the best they can to provide you that throughput, but there's no contractual guarantee for that throughput. Then we have the next level. And this is everybody, everybody else, your cellular providers, your Wi-Fi providers, your shared Starlink, not, I don't want to say Starlink, your shared satellite services, where basically what they're giving you is access to the network. And there's a theoretical cap, right? I mean, 4G, you can buy a 4G Cat 18 modem that's rated at 1.2 gigabits per second. I don't think you're going to get 1.2 gigabits per second. What you're doing is you're paying for access to the network. And there are limitations, and they try to give you throughput, but you're sharing that throughput with a bunch of other people, and because it's all roaming most of the time, like cellular, there's a certain amount of bandwidth at a tower, and that tower is there, and so they're giving, hey, you're going to get access to this network, but there's no guarantee of throughput. And that's the biggest difference between an access agreement and a best effort agreement. And so when I'm working on setting, I'm a big believer in expectations. And so when we're talking about mobile healthcare or enterprise connectivity, or even trying to stream Netflix in your RV, making sure you understand that I'm trying to achieve, an X amount of bandwidth, 20 megs for a nice little 4K video download or some variant thereof, is that the carriers are not guaranteeing throughput on especially cellular networks. There's no guarantee of throughput. And as much as I truly enjoy playing with Starlink, that's not guaranteed either. You're getting access to the Starlink infrastructure, but it's not guaranteed throughput. And so we have to manage that the best we can. I hope that wasn't too long.
No, it makes sense. I mean, we've got like enterprise wireline is what you're calling the SLA, right? You've got an actual guarantee, an actual reimbursement mechanism, and time to repair kind of along with that, right? And then I think very similar is the wireline, more broadband, right? There's no guarantee, but you're basically riding the same type of technology in most cases. So it's just a lower tier of maybe the same or similar service. Is that, you think that makes sense?
I mean, a lot of them are running the same, right? My Cox fiber is directed to Cox, but my Unity fiber is shared with other people around, but I still am paying for that 1 gig or 3 gigs, and I get that 3 gigs every time I test it.
Mm-hmm. And then last but not least is that 4G, 5G, and I think Starlink fits into this category as well, is we're all given the right to access the network. And sometimes there might be a little bit more priority of one user versus another, but not necessarily. And yeah, if it's there, it's there. And if it's not, it's not, is kind of what it sounds like you're paying for, right? Is we've built this network and you can go use it wherever you like, or, however we've said you can use it, and you get what you get kind of service, right?
Exactly.
Okay. And that makes sense to me. I think, Martin, you can definitely understand where some problems show up in that, as you move up or down that ladder, there's surely problems that show up as you get lower and lower on that tier of access technologies.
Yeah, listen, look, we can't. I think it's wrong to be too tough on Starlink and the situation here. It is as Peter says. It's exactly that. It's shared bandwidth. You unless you're on a service that has prioritized data, but even then, if you've got dishes that are all prioritized, all accessing the same cell, you've still got sharing going on there too. So, bandwidth sharing definitely happens. We've seen it. And there are certainly reports in certain geographies of it being more of a problem than others. But at the same time, Starlink's launching more satellites, more ground stations are being deployed. There's a capacity race going on, isn't there? Where as the number of subscribers increase, the coverage increases, the density of satellites increases. So it is so similar to 4G. In fact, I tend to refer to it as LTE from space. It's a very, very similar situation when we're working with Starlink as to when we were working with 4G in the early days, honestly,
Yeah, and I think that's a good point. I mean, it's very unfair to talk about these problems as if it's somebody's fault or it's, a poor design, because wireless is shared by nature, right? It's in the air and it's an open medium, right? And so there's only so much you can do to isolate that, right? You can use directional antennas and things like that, but you're still going to be sharing people within some sort of an area just because it's wireless. You're going to hear those other devices, and it's a lot different than a wire, right? It's a much easier proposition to guarantee service quality on a wire that's just your environment, not everybody else out there. And so, yeah, it's helpful to keep that in perspective, because it's frustrating sometimes when you're just not getting the service that you need. And it's often not somebody's fault. It's just the nature of the technology, for better or worse. But nonetheless, we got to solve these problems and get people connected the way they want to and make it act like wireline. And I think that's really what Peplink and Starlink is all about, is trying to make that Starlink or any wireless service that has those natural limitations behave more like that wireline service, so that it's predictable in a way that businesses are wanting to use it.
Yeah, and I think also we shouldn't ignore the fact that what are we comparing Starlink to, actually? Right now, we're being a little bit unfair in that we're comparing it to 4G. But if you look at the other options in this field, the other satellite connectivity options, it's head and shoulders above so many other different types of services out there, right? Even those services that have dedicated bandwidth over satellite are so expensive in comparison. I think we're all in agreement that the Starlink is changing the industry. It's changing how our perception of connectivity, certainly at sea and in remote locations. It's really turning everything on its head, isn't it? And it's as exciting as it is sometimes frustrating.
Yeah, I think, regardless of the technology, there's probabilities that might change, but no matter what the technology is, wireline, 4G, 5G, some sort of satellite-based technology, there's congestion and there's just interruptions, right? Those are basically the two things that you're going to fight. Congestion is going to happen, even on those guaranteed networks. Every now and then you're going to see that happen. It's much more rare there, but not impossible, and much more likely as you move, into the more shared types of connections. And so, what do you guys see in terms of congestion? I mean, that's kind of a hard to pick apart word, but how does that play out in day-to-day use case, or how do users see that or feel that?
Yeah, Peter, do you want to go on that first?
Once again, because I primarily focus in that high bandwidth enterprise space, that's actually the number one way that we identify the type of peplink we want, right? Is how do I mitigate congestion? Because as you're roaming around, or as you're streaming multiple cameras or healthcare records or PACS imaging files, congestion is visible very clearly. We can see the different carriers all trying their best, right? Trying to give us that connectivity, but we're fighting with everybody else on that network to use that same connectivity, and we're all trying to get our piece of the pie. And so, one of the ways that I mitigate that is quantity, right? If I have 2 AT&Ts and 2 T-Mobiles and 2 Starlinks and 2 Verizons, or 10 and 10 and 10, I can overcome or at least combat congestion, because that definitely, for us, it's where we see the largest challenge, is how to achieve the bandwidth we want when we're congested. Because when you're great, your phone hotspot when you run a speed test looks great, right? It's when it's not great. It's when you're trying to continuously stream large amounts of data over a period of time that we need to be able to combat congestion.
Yeah, and it's, congestion can be hard to see sometimes from a user, I feel like, because, there's different methods that these networks use to deal with that, right? Again, this isn't a bad thing. They're trying to make it work as best as possible for everybody. And so they have to use different strategies to, share the pipe as much as they can. But, so they'll do things like burst your traffic, right? So if you watch somebody on a throttled or some sort of congested connection, you'll see them peak up to 10 megs, and then they'll drop down to no megs, and then 10 megs, and then no megs, right? They'll do this bursty kind of thing, and that's fine for downloading files, right? You're going to average out some sort of pretty reasonable speed, and cool, we'll kind of let people take turns. But when we're doing a real-time call like this, up, down, up, down, up, down, or latency going from 50 milliseconds to 500 milliseconds, that ruins these types of applications. And so, that's where you hear people all the time, like, oh yeah, I've got gigabit Comcast at my home. I'm not trying to pick on anybody again, right? I've got a gigabit service at my home, but gosh, my Zoom or Teams just doesn't work, right? I can run a speed test, I'm getting 800 megs, but my Zoom is garbage. I think a lot of times that's congestion, right? That's that kind of boogeyman that nobody really understands why it works like this or it doesn't work like this. It's just kind of nitty gritty stuff that's not very intuitive for you know, the users out there trying to just make their calls work.
People joke, don't they, that the you know, the killer app for Starlink, at least at the beginning, has been speed tests. You know, that everybody deploys Starlink, which is incredibly easy to do, powers up, sorts itself out, gets you connected, and then they immediately do a speed test. And typically that's a really nice result. But as you say, when we look at doing this in the field, and when we're combining multiple Starlink, cellular as well, when we're really pushing for as much bandwidth as possible, it becomes about the quality and reliability of the link much more than the total bandwidth. Because when we look at bandwidth itself, and when we see those peaks and we see the latency rising as we are loading up a connection, and then the burst finishes, and then you're throttled back and your buffers fill up, it's a really messy connection in that respect. And needing a technology that can spot congestion or spot the symptoms of congestion and react to it and dynamically deal with it, that's what Pepplink's been doing on cellular for so long, and it's just a natural step for us to be treating Starlink connections in a very similar way to get the best out of them.
Yeah. So I'm going to switch over and I'm just going to dive into a unit that I've got set up here. I've got a Starlink and a 5G connection, and I think we can start to see some of these things in action here and start connecting dots for some people. And for those of you watching, we're going to use this as a way to kind of step into the configuration aspect of, you know, we've talked a little bit about the problem and the different connections out there, and now we're going to dive into how do we actually use these connections together to solve these problems for people. So I've got a router here. I've got the Peplink BR2 Pro. I've only got one of the cellular connections in use. So, you know, practically speaking, this would totally apply to a BR1 Pro 5G as well. I've got a Starlink connection on the Ethernet WAN, and then I've got a T-Mobile 5G connection on the built-in 5G radio. And so you can see I've got those two connections there. And then I've got a couple other SpeedFusion connections down here. I've got a SpeedFusion VPN to a privately hosted Fusion Hub over in Azure. Oh, and I just got logged out. I'm going to pause my share and log in quick again. Okay, we're getting back in. Okay, so I've got my BR2 Pro here. Again, I've got that Starlink connection plugged into the Ethernet port, and then I've got the T-Mobile 5G connection. I've got my privately hosted Fusion Hub on Azure. If I've got business applications running, I can send traffic over there. And then I've got SpeedFusion Connect. I've got two different tunnels set up there. I've got a hot failover and a dynamic bonding tunnel set up. And so I'll show you how I'm using those here and kind of what that looks like in practice. So we said, you know, congestion and the latency spikes is kind of our enemy in terms of, you know, what makes real-time video and voice applications go bad and what makes them kind of unpredictable. And it's those fluctuations in that latency. So these are those same three SpeedFusion connections that we showed you earlier, and we're using them in different ways here. So on the SpeedFusion Connect, I've got a hot failover, so I'm using Starlink as the primary. I'm only sending traffic that goes through that connection out Starlink, and then if that fails, it's going to seamlessly switch me over to that T-Mobile 5G. So I'm not going to burn my T-Mobile bandwidth. I'm just going to use the Starlink whenever it's there. But for other applications like what we're doing right now, I want to use both at the same time. And so I've got Zoom and Teams and those applications protected through dynamic weighted bonding. So it's actively using both of these connections at the same time. But my file downloads, my file uploads, they're not going to use T-Mobile and Starlink at the same time. I've only told it to use that combination for the really critical applications. So, you know, I'll spend that extra bandwidth on the real-time stuff with T-Mobile and Starlink, but I won't do that for, again, the regular traffic that isn't as important. But nonetheless, Martin, you said Starlink kind of works like LTE from space. And I think the first thing that I see right away is, yeah, I see that here, right? The latencies are almost identical between a 5G connection and a Starlink connection. But one's on the ground and one's up above me. And so I think that's pretty interesting just from a technology standpoint. But do you want to just talk a little bit about kind of how that differs from the traditional satellites and, you know, where latency was on those versus Starlink?
Sure. Yeah, I mean, so there's two things here for me, and you encapsulated it beautifully there, where LTE is like left to right and Starlink is up and down. And whenever we're thinking about reliability and connections, we want those connections to come from different places, right? So even if we're just doing cellular and we're doing directional antennas, we always try and point our antennas in different compass points to get different towers, different operators. And this is just an extension of that, where we're using a different technology and getting the connection from a completely different location. So that's, as a first step, is brilliant, obviously. And then from a latency perspective, yeah, I mean, Starlink latency has been really, really good and very comparable to LTE. And if you compare it to other satellite systems that are out there, of course, those satellites are much higher, much further away. Latency is considerably higher than what we see on Starlink, and this is why everybody's excited, right? So finally, we've got a satellite link that not only has really good bandwidth, but also has a latency characteristic which makes you feel like you're just connected to the internet normally. Yeah, it's brilliant.
Very cool. So yeah, I've got the graph up here, and you can watch over time. These will populate with different statistics for each connection, but nonetheless, yeah, they change. Each one of them changes minute by minute, second by second, and it's nice to see that we have satellite technologies that perform this well, though, because when you're combining these connections, it's more ideal if they behave somewhat similarly, right? So if you've got latencies that are like 800 or 900 or 1,000 milliseconds, like a traditional satellite, combining that with a terrestrial 4G, 5G isn't always as useful as you'd like it to be, right? You can fail over, but actively using those together isn't going to be as effective, because the ground-based stuff is going to arrive very quickly and the satellite stuff is going to arrive much later than that. And so putting it all together slows everything down. But when you've got those latencies closer and you're only fluctuating a little bit here and there, it's a much more effective combination and just works for all kinds of applications better. Last thing I'll show you before I hand it over to you, Martin, is just how I set this up, right? So I've set this up already. I'm not going to walk you through every single step of the configuration, but the really important part is, number one, how do I get that SpeedFusion Connect established? And then how do I actually get the traffic that I care about over there? And so if I look at my SFC Protect tab over here, I clicked on this client mode for outbound access. So I'm going to protect anything that I'm sending out to the internet as kind of the background on that. And here I've got this SpeedFusion Connect profile. And so I've set up these two different profiles. I've got this hot failover profile. And to do that, I just said Starlink is priority 1 and T-Mobile is priority 2. That's it. That's hot failover. So the router is going to know, hey, if Starlink's healthy, I'm going to use that. And if it's not, then I'm going to shift those packets right down to that T-Mobile connection. So it's pretty straightforward, right? Didn't have to do a whole lot. There's a lot of settings in front of me, but I didn't have to use all of those. I just had to set those priorities, and I could have just clicked save there if I didn't want any more profiles. But to do the dynamic weighted bonding, it's not much different. Again, I've just set the priorities to 1 and 1. So I'm combining those two links actively. Now, sometimes you'll see different combinations where you've got more links, and I think Peter will get into this, but you could have multiple 1s and then you could have multiple 2s or a single 2. So you can kind of group your connections together in strategies that you think will work well. So if I've got a really reliable wireline, I could fail over from that just as priority 1, and then I could have a Starlink and a 5G combined as priority 2, or I could have 2 Starlinks for priority 2. So again, when you map out those like priorities, that's using them at the same time, and then you're setting your failover order there. So again, lots of buttons you can push, but you really don't need to push almost any of them. So nonetheless, that was all set up before. Now, the only thing that I had to do after that was set the outbound policy so that I would actually push the traffic that I was concerned about to those right places. And so I'm using our in control outbound policy manager. So if I go under network settings, I can go to outbound policy. And so this test profile is the one that I set up. And so I've got two profiles here, two rules here. I've got this real-time conferencing rule that I set up. And so all I did to do this was I came under here, the destination is software as a service. I think by default it's set to any, but these are applications that we've built real-time signatures for so that any traffic that you're sending to these applications or services are going to be immediately recognized and sent to the place that you want it to go to. And so I've picked a bunch of popular real-time applications here: Zoom, Skype and Teams, WebEx, all those fun services. And then I've set it to a priority algorithm. So in my case, I know I would prefer it most to be on this dynamic weighted bonding where I'm actively using both at the same time. If that's not working for some reason, then I'm telling it, okay, fail over to that hot failover. And if that's not there, then push me over to that privately hosted Azure Fusion Hub that I've got. So in my case, I have a lot of options that I can step through to and still keep my applications protected pretty well. Last but not least, when none of those that I've listed out are available, what do I do? And in this case, I'm telling it, go to the next rule. And then this is terminate sessions on link recovery. If one of these links becomes healthy again, do I want to push my traffic back up the ladder to those links? And in this case, I've said yes. The only other rule that I've got is this default rule, and this is just telling me, hey, use Starlink first. For anything that's not those real-time applications, I want to just use Starlink because that's cheaper bandwidth in my world. It's cheaper than the 5G connection I have in terms of metering. So in my case, if it's not Zoom or Teams or one of those real-time applications, then it's gonna hit this rule and pick one of those two. So that was really all I had to do. If we go back to the router, you can see this is that private profile that I've got. And then I've got the outbound policy here. These are those rules that I set up. And so that's how it flows, right? I don't have to do much day to day. I don't have to think about it, right? Any laptop that I get on this router is going to protect Zoom and Teams. It's going to send it that right way. And my Netflix, my, cat videos, those things are just going to go out Starlink and not get metered for me. So again, there's a few steps in there, but at the end of the day, you don't have to push that many buttons to get it all working and protect those applications that matter to you. So Martin, I'll stop sharing my screen and hand it over to you if you want to walk us through a few things.
I've set up a demo. Well, it's not really a demo. I've got the environment here together, which is actually a deployed site. This is my parents' house. And as we all know, when we're giving support, the parents become the most important people that need support in our lives. They are quite demanding as a customer. Interestingly, my current situation is that my Starlink has a fault. So that's kind of nice. I'm going to get to show you today not only the configuration that we're typically using, but also how well it's coping with failover to cellular. So this is a Balance 20X. We've got a residential Starlink on WAN 1, and I've got a Vodafone 4G connection in the 20X itself. Let's just go and have a quick look at the UI. So we can see that the WAN, which is the Starlink, has failed its ping test, and I will investigate that in a minute. Let's pretend it's working, and I'll walk through the configuration, show you how I've got it set up, and explain why, and then we can have a look at the Starlink bit in a second. So I'm using SFC Protect here as well, and if we look at that configuration, I too have got two tunnels set up. I've got the first one, which is dynamic bonding. Dynamic bonding is amazing on 8.3. This is the release candidate 2 running on here at the moment. I love dynamic weighted bonding. Peter's going to talk about it in his demo in a bit, but it's just rocking my world when it comes to how successful it is at combining these things. And I've got two tunnels here. I've got the primary tunnel, which is dynamic weighted bonding, and then I've got a second tunnel, which is WAN smoothing. And for me, I like to generally push traffic out to the internet direct, and then I like to use the bonding for specific applications or specific devices. And particularly when it comes to WAN smoothing I like to use for real-time stuff like video and VoIP, because it just gives me the best possible chance of getting that connectivity through. And we'll look at how we do that as the next step. So I'm routing in this case by both applications. So I clicked here, and you'll see that I've got my two tunnels, dynamic rated bonding, and then the subtunnel, which is WAN smoothing. And for WAN smoothing, I'm sending Zoom and Skype traffic, or Microsoft Teams as well, because we do a lot of that in our family, sort of, especially around Christmas time. So this guarantees that traffic because it's duplicating the packets over both Starlink and Vodafone when they're both happy and healthy links, that is. And then for general bonding, I'm putting the business apps. And the reason I'm doing that is because what I want to do is bond the upload path on LTE and Starlink, because there's a lot of file transfer that goes on. There's a lot of dumping of photos from cameras into Dropbox. There's OneDrive usage. And Starlink, in this particular deployment, we're seeing around about 10 meg upload. I can get another 10 to 15 meg on the 4G connection. So by bonding them together, it's just a much better user experience. Things happen faster. I should mention that the 4G connection in this case is a Vodafone unlimited SIM here in the UK. It's not truly unlimited, as very few things are. I think generally speaking, it's about 650 gig a month. If you hit that too often, then Vodafone tend to get a little bit upset. But for all intents and purposes, and for the amount of traffic that moves, this configuration works very well for them.
Shown, I guess, there's a couple different things that you and I have already shown. So number one, Martin and I basically achieved almost the same thing using two very different tools. And so I used In Control to manage my policies, where you're logged into the router and you just use the SFC Protect tab to set up pretty much all of this as well. And neither one's right or wrong. They're just both valid ways that you can do this depending on kind of who you are and how many devices you're managing. And so I'm glad that you walk through this way as well, because for somebody that's just got one box, this is the easy way for sure.
And that's exactly it, right? If when we're managing hundreds of devices for customers, when it's a standard kind of deployment, then I absolutely use In Control and outbound policies there for that. You want to have the same configuration everywhere. Absolutely, go ahead, do that. Actually, this approach on this device, I've literally just pulled this device out of a different organization In Control to give you a clean visual today. So rather than rebuild it In Control, I just did it on the device. It's you can do it either place, of course, right? So I've done that, and then I've also set up route by LAN client, because on this network there's a VoIP handset, which is used for, obviously SIP and VoIP, and I specifically want all of that traffic from that device to go over. Oops, that's missing tunnel. That was from an early configuration. I can fix that on the fly. There we go. So I specifically want all the traffic from the VoIP handset to go over the WAN smoothing, so that we've got the best possible chance of getting that VoIP traffic, which is very small bandwidth really, across to the SIP service that we're using. So that's those two.
I think that's a great use of that client too, because sometimes it's really easy to just say, oh, I'll put my laptop in there, but then your laptop's going to do 5, 10, 15 different applications, right? It's not just doing a VoIP call, right? You're uploading files, and so suddenly you're duplicating all your traffic, instead of where the phone, it's only going to be doing voice, so it's very reliably only going to be sending those calls back and forth, and you don't have to worry about running a whole bunch of bandwidth through it. So yeah, I mean, they're two different tools, and there's a good reason for that, right? The Zoom and Teams, I don't care what device it's coming from, just protect that no matter what. And then, yeah, your phone, that's a very predictable device and one kind of use case.
We have a lot of clients that use that for like Amazon TVs and things like that, because you want that traffic not to use SSE Protect usually, because VPN blocking. So you can say, hey, if the destination is, if the source is this Amazon TV, don't use a different application policy. So
Yep. Yeah, that's a good point too. Yeah, sometimes you want to avoid it because the video streaming services are very protective about using data centers and VPNs and those things. So yeah, those are things you don't want to necessarily run through SFC Protect.
Exactly right. Yeah. And then just to talk about this briefly, so how do we identify the client? Well, I'm running DHCP on the device here, so I've come into status and client list, and I've actually done a DHCP reservation, which you can do when by clicking on the button next to the device, which is great. So that then locks that device to that IP address, and then which helps you with routing of traffic and identifying it later. But also, what's cool about that then is if that device, and I've done that same thing to the printer as well, if we know that the IP addresses of the devices aren't going to change, we can then use InTouch. And I love InTouch, and I can't do a webinar without showing it. So this is what we're going to do right now. But it's also highlighting that when you're on a service like Starlink or indeed 4G, and you're behind carrier grade NAT, so there's no inbound routing possible. One of the big benefits for remote support, which I do a lot on this particular deployment, is this ability to do InTouch, which gets us around the need for inbound port forwarding, as it creates this proxy connection to that device on the network. So here I am now at that VoIP handset, and I can connect to that and manage it easily remotely. So yeah, it's a big deal.
This capability is so big, and you said it right away, is Starlink does not allow inbound access, right? So you can't do port forwarding and reach out to these devices. You need to use something like this to kind of you're not breaking the rules, but it's technically a different way to do it, but nonetheless you get that experience of, oh, I can log into my device remotely, and yeah, I don't have the security exposure of public IPs and open ports, and it's a much cleaner way to get into these little devices. And
yeah, and even on the sort of the business and the enterprise Starlink product, where you can have a public IP address, you can request it and they'll assign one for you. It's still, the idea of opening ports on public IPs just freaks me out, especially in these kind of remote deployment scenarios where you've got devices like a VoIP handset that you wouldn't necessarily, in this case, think about security updates for, or necessarily maintain in the same way you would if it was a full enterprise deployment. So I would much rather, even when there is public IP addressing, use a tool like InTouch, because then you're not only have you got user level permissions and security about who can do it, but you're not increasing your surface area for attack by having ports open unnecessarily.
Yeah, it's really easy to gloss over the risks of just opening a port for a web interface on a printer or a phone, because you don't know how vulnerable or secure that device's web interface is, right? If that's publicly exposed on the internet, there's ways that people may be able to compromise that device, and then all of a sudden now they're in your network because they got into that phone and that phone's on your network, where this way there is no exposure, right? It's going through in control. It's not an inbound port that they can sit there and probe and beat on. They have to have a login to your account to be able to see that device. So very, very different way. And you don't have to set up any infrastructure either. This is all built in. There's no VPNs that you have to set up, no extra settings other than what IP address and port is my phone at.
Exactly right. Yeah.
Yeah, it's just an added benefit beyond protecting those applications. It's just that day-to-day, how do I keep my stuff working and do what I want to do on top of that user experience quality. Cool. Well, thank you, Martin. Peter, I think you're going to take it another step further and show us kind of a start to finish from scratch configuration.
I am. And so what I have is in my demo is an MBX Mini with AT&T and T-Mobile 5G. Ignore the fancy antenna there. And then outside I have, we just built this for playing around. So I've got my little pneumatic antenna mount with my Starlink mounted to the top of it. I kept getting these errors that said, was it obstructions detected? I'm like, the sky's open. I don't understand. So I figured if I just got it higher than the trees, I wouldn't have obstruction detected anymore. And so I've got my Starlink mounted to a pole, and then I've got my MBX, and I've actually, if you notice, this device has been online for 29 minutes or 31 minutes. I have factory reset the device. I'm holding the power or the Ethernet cable for my my Starlink, so I'm going to show configuring this from scratch, and that way it just allows people to see kind of how we tune things or how I set it up for deployment. So here's my MBX Mini Starlink. So you can see my T-Mobile, my AT&T are connected right now. And so I'm going to go to now I'm running 8.3 firmware. Some of the features, and Martin has already alluded to this as well, but 8.3 is an RC2. It's going to be GA very, very soon. And I know there are some frustrations out there with the bonding performance of Starlink and 5G and 4G. I just want to give you some peace of mind. I'm going to demo this today. That we know this, and we've identified how to make this better, and I'm going to show you how to fix that. But we are going to be running 8.3 for the demo, as well as once it goes GA, and SpeedFusion Connect, SpeedFusion Protect gets updated to 8.3. You're going to see improvements here as well. So the first thing I'm going to do is I'm going to log into my router. So I'm going to go to Settings, Remote Web Admin. And if you've never logged into the router before, it's going to ask you to set up a Wi-Fi password. Here you can actually set the SSID. It doesn't look like you can, but it's kind of gray there. So I can actually change this to Starlink webinar and then give it a password. And then click Save and Apply. If you're logging in locally to the device, you actually will ask you for an admin password as well. And so just be aware of that. So I've logged into the router. You can see my T-Mobile and my AT&T are there, and I have my priorities. So by default, the router is going to say WAN 1. And the reason why this is unplugged is because if I plug that in, T-Mobile and AT&T would be disconnected right now, because WAN 1 would be my Starlink, and I'd only be connected to Starlink. And so this is important here because there's two types of priority. You have interface priority. In other words, is this interface working? And then you have bonding or SpeedFusion priorities, which is the hot failover that Travis alluded to earlier. The interface priority will supersede SpeedFusion priorities. So if the interface is down on here, it can't be used in SpeedFusion. And so I'm going to move my WAN 1 down to priority 2 to make it active. And that way, when I plug into WAN 1, my Starlink and my 5G will be active. So I'm going to go ahead and turn that on.
Yeah, so basically, if you'd not done that, it would kind of disable the priority 2 connections and would have turned on that.
And then I would have lost access to, like, it would have switched over to the Starlink, and then In Control would have reset me. And it actually still might, as a priority WAN, as a part of the WAN, it might still kick over, which is one of the cool things about SpeedFusion. And you'll notice this when we get faster here, or as we set it up. So now I've got my T-Mobile, my AT&T, and my Starlink all connected. They're all on the internet. So now I can set up I'm going to set up 2 different VPNs. One is SFC Protect, and the other is going to be just a regular SpeedFusion demoing some of these 8.3 features that we talked about. And I'm going to do the SpeedFusion Protect really fast because they've already done it. So we're going to go to SpeedFusion Protect. I'm going to client mode. So there's 2 types of modes. We have relay mode, which is like if you want to relay it through your house. So say you have like a BR2 Pro 5G or a mobile RV, and you want to use the high-speed cable modem at your house for internet, you can actually set up relay mode right here. Or we're going to do client mode, which is outbound. So I'm going to use the client mode. I'm going to just choose automatic, but you could choose the location. I think you said that one of these or a couple of these might be 8.3 already, but we're going to do automatic. Hit OK.
Yeah, automatic. It's been connecting me to an 8.3 node on the other side automatically.
Nice. And so once I choose automatic and I hit OK, you're going to see now this SFC shows up. So I can click on the SFC, and we want to make sure 2 things. One, we want to make sure dynamic weighted bonding is enabled. That is very, very important. The other thing for Starlink specifically and congested LTE networks would be TCP ramp up. TCP ramp up is a new feature in 8.3 that's going to improve the handling of TCP traffic, which Starlink uses TCP acceleration. It's super, it's going to dynamically change how your upload and download throughput as the SpeedFusion Protect systems come online. So dynamic weighted bonding, and then I can hit save and apply changes. And that SpeedFusion, now we can create subtunnels like WAN smoothing and forward error correction, but once again, it's already been demoed. So I'm more going to show some of the differences in tuning versus the actual subtunnels here. And then I'm going to go to advanced, and I'm going to create a SpeedFusion connection to my SDX running 8.3 in my office. And this is going to allow me to better showcase some of these 8.3 features, as well as some of the tuning that people might be looking for. So I'm going to give my router a local ID. Oops, sorry. There we go. And then I'm going to create a new profile. Put in the connection name and the pre-shared key. That pre-shared key will be invalid right after this webinar. And then I'm going to put in my URL to my server. I'm going to enable dynamic weighted bonding. I'm going to enable TCP ramp up. Now on my SDX in my office, I've also set up this tunnel to go to a mobile device called Starlink and use TCP ramp up. So I'm getting the upload and download capabilities. And then I've got dynamic weighted bonding enabled on both sides. So I'm going to have upload and download TCP ramp up enabled, as well as the new 8.3 dynamic weighted bonding. And I'm going to hit save changes. And if I go back to my dashboard,
I just want to jump in quick here.
Yeah.
One thing that, you know, a lot of people wonder about is, you mentioned at the beginning, right? You're not seeing quite the performance you wanted to bonding Starlink and 5G together, right? That's hard, it turns out, right? This is really actually really challenging from an engineering perspective to do that. And very few companies can do that, but more importantly, very few companies do that in a way that is actually optimizing for these highly variable networks. There's a lot of enterprise SD-WAN solutions out there that are just predicated around those SLA, or at worst, those broadband links that are highly consistent, right? It's more of a failover solution. And when you start throwing these highly dynamic connections like 5G and Starlink at these enterprise SD-WAN devices, the performance goes way down. They're just not designed to accommodate the link behavior that you're seeing out there on these links. And that's what we're doing. We are wireless first, and every single firmware we are further optimizing and refining how much performance you can get out of these multi-link combinations. And that's, I think, Peter, what you've seen exactly in 8.3.
Yeah.
There's a huge improvement there.
Well, in dynamic weighted bonding, and I mean, Martin was alluding to it as well, it is dramatically improved. The way that we do TCP handling, congestion detection, the way that it handles packet loss as a means of detecting congestion and or latency as a means of detecting congestion, so that we're not simply dumping a whole bunch of data that's failing to communicate with the, to transfer. And so the new dynamic weighted bonding is really improving how data is handled. And that's where we're going to see a bunch of improvements. And I am just waiting for this guy to after all those VPNs established there. So once again, we're doing this live. And the reason I'm doing this live too is because it's sometimes you have to wait for it to like configure and get its settings. And so you might think, oh my gosh, it's not working. No, it's working fine. It's got to connect and authenticate and get those VPNs connections going. And so that needs to be there. And obviously my SpeedFusion tunnel is not connecting. So I did that really fast. I just want to make sure I did. I see what right there.
We mentioned TCP ramp up a couple of times, but actually that's we should talk about what it is. I suppose that's the TCP ramp up. That is actually the initial duplication of packets to generate more traffic when a session starts, to increase the TCP window to enable then subsequent subsequently more bandwidth to be sent, right? So on
Yeah.
a TCP session, you see that normally quite a gentle ramp up. And we're kind of forcing it, aren't we, with TCP ramp up to ramp much faster. Very clever.
It also helps with that TCP acceleration that's being handled by Starlink. And so like they complement each other, right? We're helping complement the technologies so that they can, there we go, now it's created. So now that I've got my 2 tunnels here, to make this faster for me, I'm gonna go ahead and create an outbound policy that tells my router to use these connections. So I'm gonna go to my advanced tab, and that will connect here in a second. So I'm gonna pause my screen real fast, just log into my SDX, make sure I typed all that stuff right. I'm so sorry, everybody. Let me just make sure I typed oh, there it goes, connected. Okay, see, just had to wait. There we go. I was being impatient myself.
Everything feels so much longer when you're live.
It does. Well, you're on a webinar, like these people are watching and you're like, I want it to work. And so right now,
that's what downtime feels like, right? Downtime feels just like that.
It's so horrible. So the other thing is, and I don't know, Martin and Travis, if you feel this, but a lot of times people connect to SpeedFusion Connect or their VPN, and then they're like, oh, I'm not seeing any improvement. And the reason is because you don't have those policies set up. And so Travis and Martin showed you guys how to use those policies. I'm going to show you a third way to use the policy, and that's outbound policies directly. I figured that would be the best way to do this, right? You showed in control. Martin showed using SFC Protect. So I'm going to use outbound policies. And outbound policies built into the router are about the exact same as outbound policies in control, with the exception that we don't get regional based routing and we don't get SAS. So if I add a rule and I go to my destination, I'm only going to have IP, network, and domain name. I'm not going to have like SAS applications like Teams. Those you either have to use SFC Protect or you have to use in control to get those databases. So for me, I'm just going to set up a generic policy. I want to bond. So I'm going to say, I like the way you guys are doing that, dynamic bonding. Dynamic bonding. And then I'm going to simply say, I want all my traffic to go over my SpeedFusion to my office and then back up to SpeedFusion Protect. And the reason I'm doing that is because I have 6 gigabit internet off at my office. So if as I'm maneuvering around an infrastructure or moving around the country, which I do often in my Sprinter, I actually want all my traffic to go over my data set, my office. And then only if like if the power loss or whatever, if that's not available to me, then I have a backup connection, which is the SpeedFusion Protect. And once again, Travis and Martin showed other cases, so I'm just showing a different use case. So here, what I can say is priority use my SpeedFusion, and then secondary use SpeedFusion Protect, and then fail through the next rule, and this terminate sessions on recovery will make sure everything is on my bonded, the bonded VPN that I want. So I'm saying in the event that both of these don't work, just load balance, go out, whatever, just use your auto load balancing capabilities that the Peplink does. But otherwise, I want you to send all traffic out one of these connections. I hit save. You'll see this show up here, and you can fine tune this, but once again, for the purpose of the video, just showing a third way. And I can hit apply changes. And now all my traffic will be bonded to my SpeedFusion in my office. And then if that goes down, it will fail over to SpeedFusion Connect. And once that's done, we'll let that reset and wait for it to apply. It was really funny because Martin, you mentioned your Starlink being down today. When I was setting up for this demo, I have multiple Starlink, and for whatever reason, I couldn't get mine to turn on. So right before this webinar, I'm like scrambling to grab my my other Starlink because I couldn't get it to. It kept saying it wouldn't power up, and one of my friends commented that I might not have had that cable plugged in all the way.
Yeah, that cable is annoying, right?
But even technicians, we do have challenges, and I thought that was an interesting one because I've been using Starlink for months now, and sure enough, right before this webinar, my enterprise Starlink wasn't lighting up. And I found that to be, really interesting.
I've been looking at my Starlink whilst you've been doing yours, and there's I've got no issues with the connection to the Starlink. The Starlink's online, it's reporting as online. It's a really interesting fault. And I did a software update just before this webinar on the Starlink itself, and I think that's what's balked it. So I need to have a look at that.
I will say with some of my enterprise customers, and I forgot to mention this, we do fine tune. So all I did here is I just plugged in the Starlink to WAN 1. But actually what we do when we set up Starlink for production environments is I actually go in and I go into this WAN 1 and I actually change this to 1500. And then I set my health check interval to 10 seconds instead of 5 seconds. And I do a ping and I ping my DNS servers, or you can set it up to like ping DNS, but they actually recommend the DNS servers in Starlink. This will help mitigate false downtime with Starlink. So setting the MTU, the negotiation that Starlink has is 1500 on their devices. And then if we do a ping test with a slightly elongated health check interval of 10 seconds instead of 5 seconds, you actually will get more stable. You won't get that flapping of up and down that sometimes might occur. So if you see that where you flap up and down where it says, Starlink failed, Starlink connected, Starlink failed, by changing this to a ping with the health check interval at higher, we were actually able to stabilize the Starlink health check detection. I'm going to cancel that because I don't want to reset my connection right now, but I did want to add that note. So now I've got my SFC Protect and my Speed Fusion, and I wanted to do this as a final for me just to show the difference between 8.2.1 bonding and 8.3, if that's okay. And it is incredibly cloudy outside here in Florida right now. We don't really get winter weather, but we are right now. And so my connections might or might not be that great. But it's a really neat demonstration. So I'm going to click the little arrow here and I'm going to pull up my Speed Fusion Connect, and I'll see my WAN. So I've got a Starlink, my T-Mobile, and my AT&T. And if I do a download test and hit start, you'll see that T-Mobile, look at that, T-Mobile and AT&T just are barely doing anything. And you can see Starlink kind of carrying the load here. And we got some packet loss and, getting, 45, 46. So it really makes Starlink look really good right now. So, and not saying it's not for any Starlink employees that are on the show, but it looks good. Now,
I think it's interesting too, that cellular 2 connection is having some troubles. That latency was going.
Yeah, it went through the roof, right?
Yep.
So now let's try with TCP ramp up on 8.3 with that same connection. So let's see what that looks like. And so you'll see some packet loss there, but look at T-Mobile now. And so, and it'll start, and this is a brand new setup, but as we go, you'll see those increase. So you'll see Starlink is increasing. And if you do, a long test, more than 20 seconds, you'll actually see that continue to ramp up. If you do like 120 seconds, you'll see that Starlink ramp up, but you see the difference between T-Mobile and Starlink. I'm actually aggregating 5G and Starlink together. And then the AT&T is sitting there just feeding some data, right? It's down there just feeding it some extra data. But I find that to be incredibly valuable as an understanding of what's coming here in 8.3 with SFC Protect and TCP ramp up and things like that. And so I just wanted to show that off for a second.
Yeah, I think this is really, what you just showed is really powerful to me, because it demonstrates you're not moving, right? You're in one spot. But those connections moved all over the place.
They go up and down, and so.
And each one did it at different times and in different manner, into different degrees of severity. Yeah. And you didn't change anything. You didn't have to do anything different on the router, right? That's dynamic weighted bonding. That's the difference, right? Our algorithms are designed to react to those changes quickly. And it was fun to see that actually shift traffic back and forth too.
Should we do a Q&A?
Yeah, I've been going through and punching in answers as I could here. But yeah, let's dive in there. I'm just finishing one more response here. Yeah, all right, yeah, we're just after the top of the hour here, so that will be all the demonstration we'll show today, but yeah, we're going to dive into the Q&A, and those who want to stay on, great, we're going to keep going and answer some questions.
There's a guy, Ben, that asked, what's the average time to get Starlink service, and have a way. I wish we had a Starlink rep on the call here with us. That'd been kind of fun. There are tricks. I'm just going to give you my trick, and I don't know if I'm allowed to say this or not, but if you buy the RV one, you'll get the Starlink, and then you can upgrade or you can transition that over to enterprise or even business or a residential. And so if you are waiting and you want to play with this now, you can buy that RV service, and then the same dish can be used for all the different plans. And with the RV one, I just ordered I was waiting for the enterprise flat dish. I just ordered the RV flat dish, and I was able to get that. And then I can transition that over. So now I'll be mounting the flat dish now on my Sprinter van. So I'll have 4 5G, and then I'll have the Starlink flat dish on my Sprinter as of next week. So that, but yeah, all I can say is that if you're on the waiting, yeah, there is no ETA. So maybe look at getting the RV one if you can.
They're building a network with space lasers. It's hard for them to keep up with all of this. Like it really is just a absolute feat of engineering that they've deployed this and have dishes even to give people right now. So yeah, the wait time is frustrating, but I think
I'd be amiss not to point out that there are actually some Starlink resellers out there that might have some stock in their warehouse.
There you go.
If anybody was looking for high volume to dishes, there are some interesting people you can speak to. Just put that.
Ben is a Starlink reseller. Is that true, or?
Yes, we are. Yeah. Ben's a Starlink reseller. Yeah. We're focusing on enterprise, of course, and doing lots of really interesting work around enterprise Starlink and 5G in particular. Of course, there's lots of demand for it. So it's pretty busy times.
That's another really unique thing about Peplink and Starlink is this, this solution works great for enterprise, and we've seen it be able to go well beyond other enterprise SD-WAN solutions that couldn't handle as many Starlink dishes as the customer wanted and things like that. But this is also super relevant for you and me and your mom, right? I mean, it doesn't take a whole $10,000 worth of kit to make this work, right? You can do this with the Peplink BR1 Mini. I mean, you can spend a few $100s, and that's not going to give you the 5G side of it, but you can get 4G in Starlink. So yeah, people with much lower budgets than an enterprise can actually afford this technology to solve their problems, so they can, work like those enterprises do too.
Really good, it's a really valid point. As we talk about Starlinks and 5G and combining them, and it becomes a set of Lego bricks, right? Particularly in Peplink's world, how we can then take multiples of each, multiple operators, multiple technologies, multiple dishes, and combine them in a way that gives you hardware and technology redundancy. That's where this gets really exciting. I know, Pete, you've done a bunch of large scale kind of dish deployments, and it's been really exciting. Every time we look at this and we have a customer demand that comes in that says, I need this amount of bandwidth in this location, it's just a question of adding more links, right? That's all it boils down to. You need a bigger share of the available bandwidth on both Starlink and 5G. And to do that, you need more connections. And that's why this whole Peplink Starlink combination is exciting.
I see a lot of questions about VoIP and WAN, like WAN smoothing and FEC. And I know in our original conversation, we talked about that. And if people want to have that conversation, I don't mind spending another 5 minutes on that as well, and just kind of answer. We could probably knock out like 30 of these questions with the same conversation. But when to use WAN smoothing versus FEC versus bonding, and it's kind of an interesting, and I think all three of us have our own unique take on that as well. FEC, forward error correction, has really been built for the broadcast industry for one-way audio or one-way video or audio transmission. The idea is you're trying to conserve bandwidth. So conserve bandwidth overhead but also improving quality. So the idea is, if I've got a transmit, I'm trying to send a 1080p video stream upload up to my net, up to a whatever my decoder is, then FEC allows you to add either 13 or 26% overhead to add parity bits for reduced jitter and latency and without consuming as much bandwidth. And so it gives you a little bit of protection, but not the complete protection. WAN smoothing is designed for video conferences like Zoom and Teams and VoIP and things like that. WAN smoothing adds 100%, 200%, or 400% redundancy for the lowest latency, the least amount of jitter, and best failover. If you really want to show off the power of a Peplink router, set up a router with 2 or more internet connections, enable WAN smoothing, start a VoIP call or a ping test, and unplug one of your internet connections. It's going to be seamless because it's sending redundant parity bits at 100%. So if you have 2 WANs, one WAN is they're both being used equally for that transmission. If you have it on, like if you have 3 or 4 WANs, you can enable, speed fusion or WAN smoothing medium or WAN smoothing high, and have even further protection, like a 200% protection. I personally, in modern 5G world, I don't recommend that because the latency and packet loss isn't that high in 5G and Starlink, and this is a Starlink webinar, but you can do that. And so for VoIP and Teams calls and things like that, WAN smoothing works. That being said, and this is where we might all differ, I'm all about getting the most bandwidth out of my connection. And with DWB and TCP ramp up and the new features of 8.3, I found myself more and more often turning off WAN smoothing and FEC and letting dynamic weighted bonding handle that call. Now, that's brand new with 8.3, but I find myself seeing that the benefit of DWB, and DWB came out in 8.1.3, but it's been improved, like 8.1.3, 8.2.1 was improved, and then 8.3, it's even more improved. But I find myself less and less using WAN smoothing now that DWB with 5G, at least with 5G and connections like Starlink and 5G, I find myself not needing it as much and only using it when there's packet loss, like where I'm in a rural area where I'm seeing lots of packet loss. I don't know if Martin and Travis feel about that, but that's sort of what I've started to see. And that it's not a one size fits all. It's you have to evaluate where you are and what your connection is to make that decision. That you can't just say, oh, well, Peter says don't use WAN smoothing. Well, you might be heavily disappointed if you're in a area with high packet loss. And so, but it seems to be, I'm seeing that with DWB, we need to use it less, and at least in my experience. So I get more bandwidth and more increased reliability. I don't know how you two feel about that, but
it reminds me of the question of like, what stock should I invest in? It depends, right? What's your timeline? How much money do you have to invest, right? Like there's a lot of different questions that go into that answer. And I think it's the same for which algorithm's best for protecting this or that as well. Do you have 2 wireline broadband links that aren't metered? If that's the answer, yes, then yeah, use WAN smoothing. You're not paying for more bandwidth on either one of those links. So, it's kind of free in that sense. So yeah, let's get the free insurance on that. But if I've got 2 5G links, maybe I'm paying a lot for those, maybe I'm not. But on one hand, they're more likely to have a problem. So I'm motivated to use, something like WAN smoothing there. But on the other hand, I'm paying for every gigabit and megabyte that goes through that. So, it depends on how much, right? It's a very situational and individual, I guess, decision on that. But the important part is we have the tools in that kind of ladder of more aggressive mechanisms to protect that traffic, right?
I think actually for me it's got a lot easier. Before 8.3, when we were looking at performance tuning, when we were looking at solving any sort of issues with connectivity for a customer, we had this fantastic tool set we could use. We could use bonding, we could use WAN smoothing, we've got forward error correction. And then with subtunnels, we could use all of those in different ways with different types of traffic. And it was actually really empowering to be able to fix issues that were for specific types of traffic very easily, actually, right? But it was still a manual process. You were still having to identify you had significant packet loss on a link, and that really, if you wanted to guarantee the traffic, you needed to turn on these features. And it took a lot of experience to do that well. What's amazing with dynamic weighted bonding now is that we're seeing it apply WAN smoothing and forward error correction dynamically on links that it identifies as having latency and packet loss issues. And when I saw that for the first time, my jaw hit the floor. Right, it was. I was doing a demo to a customer, and I said, "Oh, this is what all the icons mean on the SpeedFusion graphs, and we haven't shown those yet, but this is what it all is all about." And I thought, well, where did those WAN smoothing packets come from, and where did the forward error correction packets come from? And then I realized it was being applied dynamically. So like you, Pete, my default now is dynamic weighted bonding, turn on TCP ramp up, and then sit back and watch and see what happens. And that is that's nearly a default config.
Yeah, it's nearly, yeah.
The only times I manually go in and enable WAN smoothing is when we're doing something nuts, when we're doing something. One of the customers I dealt with in the past was a remotely driven taxis, right? And they need to guarantee the command and control signals going from a remote driving station to the vehicle, and they need to guarantee elements of the video coming back. You don't mess around then, you don't leave that dynamic, you just turn on WAN smoothing for the command and control, because you have to make sure it gets through.
Correct. Yeah, that's where that plays really key. That lowest latency connection, like a spike of high latency, is not acceptable. And so WAN smoothing then creates in. We got a really good question, and I'd like to address it. James asked. He said, "I haven't tried SFC Protect. I have a Balance 1, a residential 1 gigabit connection, and a Starlink on cold standby. Which should I purchase? Or should I purchase? I'm sorry. Which plan should I purchase to enable SFC, similar to the way that you have demoed?" And let's talk about that, because a gigabit connection is important, especially when you're talking about SFC Protect. SFC Protect, at least currently, is limited to 200 megabits per second. And there are services like Netflix and Hulu that will block because they see that as coming from a VPN. SFC Protect, and this is my personal opinion, so Travis, you might want to step in, but is designed to protect mission critical applications, Teams and VoIP and reliable file uploads to Office 365 and things where that gigabit connection isn't being utilized in its fullest. Like, I don't need a gigabit of connection to have a Zoom call. I don't need a gigabit connection to have 100 Zoom calls, right? Maybe, depending on how many video feeds, but let's say 10 Zoom calls. And so when you're looking at the SFC Protect, you're going to see the need here is protecting business applications that require that extra level of reliability. And so that's why the traffic shaping policies that Martin and Travis demonstrated in their part of the video was so important, because they're saying, hey, I'm using SFC Protect, and here's how I control the flow of different applications over the different subtunnels. But in your scenario, James, I would not have Starlink as a cold standby. I would use outbound policies to load balance that connection, unless the Starlink is way underperforming, and then in which case the Starlink and a cold standby is a good idea. I mean, some areas, right? I mean, I've seen Starlink get 20 megs of throughput, and I've seen it get 200 and 300, and even 400 megs of throughput. And so making sure that you evaluate that need, but you don't want to bond that together for all of your internet. You only want to bond that together for your mission critical data. And so that's where I mentioned in my video how you can, the WAN connection status, you can put Starlink in priority and in the same always on, use SFC Protect to bond with WAN smoothing your business applications. That way you have seamless failover with business applications for your cable modem. And then And then in the event that your cable modem fails, you don't drop your Zoom call or your Teams call or anything like that. And then the rest of your traffic uses you. So your default would be use that 1 gigabit connection and then only fail over to Starlink when the 1 gigabit connection fails. So that way you're able to seamlessly fail over your your regular web browsing traffic, but at the same time, your Teams and Zoom calls and VoIP calls and things like that get to take advantage of the WAN smoothing capabilities of Starlink and your cable modem. I mean, that would be and I mean, that's exactly how Travis had it set up in his demo. So after this video, rewind and watch what Travis did, because that's exactly what you would want to do is how Travis has it set up, right?
I definitely agree that the new algorithms are so much more efficient and so much easier to use, just so much less fine tuning that is the right default, for sure. That's the easiest default, I guess, or the most reliable default.
Somebody else asked a question that was SFC Protect versus SpeedFusion Connect. I just want to state that there's a branding update there, which even me talking on mine, I kept saying SpeedFusion Connect and SpeedFusion Protect and SFC Protect. Peplink, as they built out the SpeedFusion platform, the technologies and features of it changed. And so 8.3 firmware will give you SFC Protect. However, 8.2.1 has the same capabilities, so WAN smoothing. So your BR2 Pro 5G, if you have a cable modem and 5G, you can go into SpeedFusion Connect and still enable WAN smoothing, just like we showed you in SFC Protect. It's the same. Just the naming is adapting to the breadth of technology that's being added to this service.
I just want to show something. I don't know. So I've got 2 connections at my side, and at this point, my Starlink is not deployed in an ideal scenario. My building is a small one in between 2 big ones, so I am obstructed. So, this isn't Starlink's fault, but my connection isn't 100% as reliable as a normal Starlink or an unobstructed Starlink connection would be. And then my backup connection is my 5G, which is another shared kind of right to use type of network. So I've got 2 right to use networks. Now, when they're both active, they pretty much back each other up pretty well, but each one of them can have a problem at the same time. And that's where you have to start thinking more critically about, what am I doing? How important is what I'm doing? And, how do I actually, when I do get into that failover state, then what's my connection quality like, right? If I lose my wireline and I fail over to this backup, is my backup good enough to perform the way that I want it to? And sometimes that answer will be no, you need 2 5Gs or 2 Starlinks or both. And so, like you guys said, every situation might be a little bit different, and you might actually step into some territory where you need another link to actually give you that quality of experience that, 2 connections just weren't able to, right? SpeedFusion can't make bandwidth just appear, right? We have to use what we're given from these different networks at any given time. And so sometimes you just need more chances to have a good connection, and depending on where your location's at. I think I can show that connection instability here right now if we want to look.
The questions here around whether to use the Starlink router or not, how were we connecting to Starlink? I personally always get rid of the Starlink router and I just plug direct wired connection into the Peplink. I don't like anything else in between.
I totally agree.
Yeah, I mean, I love these graphs so much. When we see the amount of times people say, I've got a great connection, great 5G connection, or I've got a great cellular connection, and why can't I use all of the bandwidth on it all of the time? So, well, you don't necessarily have a really good 5G connection, right? You've got a connection that's with packet loss and jitter, and you've got you might be able to run a speed test and ignore the fact the speed test takes you to high latency and is effectively ignoring the packet loss to a certain extent, also through buffers to give you a result. But if you want to do anything useful with the bandwidth, if you want to have a reliable connection at all, you somehow need to mitigate packet loss and latency, right? And this as a visual is always really useful to explain that, I think.
Yeah, and in my case, I need more links, right? These two are just not reliable enough in their currently deployed manner to give me the bulletproof connectivity that I may want. And for some people, this gives them more than they want, right? Some people, this is great, but yeah, it's just, again, you have to take what's available out there in terms of different connections and providers and combine those creatively to get to where your connectivity needs to be.
And when you add those the extra connections, and you see on this graph SpeedFusion dynamic active bonding kicking in and using another link for upload traffic and duplicating packets and turning on forward error correction, it's just wonderful to see it kind of do its thing and settle down. And then when you put your mouse cursor on the links individually, and you see you've got a certain amount of packet loss and latency, and then you see the result, the overall statistics of the tunnel and how it's been improved. It's just, yeah, that's where the magic happens for me.
I think we can wrap this up for today. I just really appreciate everybody taking their time. Martin, Peter, thank you so much for taking your time to present to us all here. Anybody who registered for the webinar will get a recording emailed out. It will also go on our user forums. So stay tuned for those. Thanks again, folks.
Have a great day. Thank you. Merry Christmas.
Thank you, everyone. Yeah, Merry Christmas.
Goodbye.